So today we are going to learn longest subarray with some k, right? Okay. Let's try to analyze what is a subarray first. Let's try to analyze what is a subarray. What is a subarray? When you listen the word subarray, it means contiguous, contiguous, contiguous part of the array. What is a subarray? It is a contiguous part of the array. So what is the contiguous part of the array? So for suppose we have an array, right? Here we have an array. So what is the subarray for this? What is the subarray? Here I can say this one is an subarray for this, right? This this two three this this two three is a subarray. I can say this 2, 3 is a subarray. This this 1, 1, 1 is a subarray, right? This is a subarray. This is I can't say two. I can't say one. These are the subarrays. I can't say because they I can't say this and this is as a subarray because they are not contiguous, right? Conse consecutive because they are not in a consecutive. What is a consecutive? I can say 2, 3, 1, right? 2, 3, 1. So they are in a consecutive form. Consecutive form. So they are in a consecutive form. Then I can say it is a subarray. Then I can say it is a subarray. So here what they are saying is they're saying to give the longest subarray. They're saying to give the longest subarray. They're asking the length of this subarray. Longest subarray. Right? So they have given k equals to 3 and they are asking the length, right? So here I can say 1, 2, 1, 2, 1 plus 2, 1 comma 2, 1 plus 2 is 3, right? So k equals to 3. Can I say this has a longest subarray? No, I can't because this index is 0, 1. This is only 2 index, right? 2 index. They're asking the length. This length is only 2, right? This length is only 2. But they're asking the longest subarray. They're asking this longest subarray. Then I can say this is 1 comma 1 comma 1. This is the summation of this is k equals to 3. Yes, k equals to 3, right? And the length is 3. So this is the correct length. So this is the longest length, right? This is the longest length. Then it is the longest subarray. Then I can say this is the longest subarray. Okay. We have came to understand what is the longest subarray, and we should need to return the length of this array. We should need to return the length of this subarray. We should need to return the length of this subarray. So this is that is they are asking about. They are asking to return the longest subarray length, right? Okay, we understand. So say let us start from the brute force solution. Let us start from the brute force solution. Let me erase this. Okay. Yes. Here what I can do, I can say here I can say here one is a subarray. Here one is a subarray. Yes, we all know that one is a subarray. Here I can say one is a subarray of this. I can say this is also a subarray. 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 Right? Array itself is a subarray. Array itself is a subarray. The whole array itself is a subarray. I can say this is like this. 1. This is a subarray. 1, 2. This is a subarray. 1, 2, 3. This is a subarray. 1, 2, 3, 1. This is a subarray. 1, 2, 3, 1, 1. This is a subarray. 1, 2, 3, 1, 1, 4. 1, 1, 4. This is a subarray. 1, 2, 3, 1, 1, 1, 4. 2. This is a subarray. So these all are the subarrays, right? Okay. Here, what I'm going to do is in the better solution, in the brute force solution, I'm going to take a two-pointer approach. What I have to do here is I just need to take a pointer here. I just need to put this here, and I need to take a pointer, take a pointer here, and this pointer should need to go with this pointer should need to traverse the array. This pointer should need to traverse the array, right? For that, I'm going to take I'm going to take a two-pointer approach, that is I to j two-pointer approach. So let me take this. Let me try this two-pointer approach. We're going to solve this problem using two-pointer approach. So how can we solve this? How can we solve this? I say I'm going to take a pointer here. I say I take a I pointer and which is pointing to the first element, right? And I also take a j pointer which is which is which will start iterating from the I, which will start always with the I, right? Okay. What I say is, so okay, this, so we are going to find the subarrays for all of, for the one, right? We're going to find the subarrays for the one. What I say, okay, one is itself a subarray, right? One is itself a subarray. One is a subarray. Then what will happen? I'll move the I pointer. Then 1, 2. Then 1, 2, right? Then 1, 2. Then I'll move the I pointer. Then I'll move the I pointer. Then I move the J pointer, J pointer. Okay. Then I get the subarray. Then I move the J pointer. Then move the J pointer. Then I 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 move the J pointer. Here we've got a subarray. We've got all of the subarrays, right? So what we got? 1, 1, comma 2, 1, 2, 3, 1, 2, 3, 1, 1, 2, 3, 1, 1, 1, 2, 3, 1, 1, 1, 1, 2, 3, 1, 1, 1, 1, 4. So in this way, we have got this all of these subarrays, right? We've got this all of these subarrays, right? But what about this? What about this? What about this 2? From this is also a subarray. 2, comma 3 is also a subarray. 2, comma 3. The 2, comma 3 is a subarray. 2, comma 3, comma 1 is a subarray. 2, comma 3, comma 1, 1 is a subarray. This is also subarray, right? For that, what we need to do? One iteration is completed. One iteration is completed. J is completed, right? J iteration is completed. And we have here, this is completed. What I do? For the first element, we have got all of the subarrays for the first element. And I'll say, I am going to iterate for the second element. What I'm going to do? I'm going to iterate for the second element. Then I move the I pointer. What I'm going to do? I move the I pointer. Then I start iterating the array again. Then I start iterating the array again using the J pointer, right? Then I start iterating. Then I start iterating the using the J pointer. And I start from here because I say I always start from J. J always start from I. What I'm saying here is J always start from I, right? J pointer always start from I, right? So here I say the pointer is here now, here J, right? So okay, I'll move the J pointer. Then the subarray is 2, 3. I'll move the J pointer. 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 I will move the J pointer. I will move the J pointer. So okay, the iteration is over. The iteration is over, right? So we've got the subarrays of 1, all 1 subarrays we have got, and we have also got two subarrays for the element 2. We have got all of the subarrays, and in this way, I'm going to move this pointer, move the I pointer. So in this way, we're going to solve this longest subarray. We're going to get the length of the longest subarray, right? Using brute force solution, using two-pointer approach for the brute force solution. Let's try to implement this. Let's try to implement. Let me write the code. What I say here is, I'm gonna write the code. Let's try to code this thing. Yes. What I do here? What I do? I'm gonna take a pointer. I'm gonna take a. So what I'm gonna do is I'm going to write a for loop. I'll say I equals 0. I say I is less than, and then I say I plus plus. So this is the outer loop. So I'm going to write an inner loop. I say for j equals to I, because j is pointing I. J is always start from the I pointer. Then I say j is less than n. Then I say j plus plus. Here what I'm going to do is, I'm going to write a summation. Summation s equals to 0. Initially the summation is 0. And I say, and I take a loop to iterate the array. That is k is equals to I to j. Then I say I to j. It should need to go from I to j. And I say this loop should get the summation of the every subarray. This loop should need to get the summation of every subarray. Let's try to get what is the summation. What is the summation? First of all, I say the I pointer is here now. We just imagine the I pointer is here, right? We just imagine the I pointer is here, and I move the j pointer. Then we have got. Then what I should need to do? I should need to add this. I should need to add this. When we are at the I pointer, then the summation. When we are here, the this is a subarray, right? This is, then I say the summation is 2. When I move this, the j pointer, then 2 3 is a subarray. The summation of 2 3 is 5. Summation is equal to 5. 2 summation equals to 2. 2 3 summation equals to 5. 2 3 1 summation equals to 6. 2 3 1 1 summation is equals to 7. So we are going to add this, right? We're going to add the subarrays to get the summation, to get the k value. When the k becomes 3, then we'll get the length of that subarray, which has the which will become k equals to 3. Then we get the length of the longest subarray. That's what we should return, right? So this is for summation. Summation, to find the summation, right? Okay, of the subarray. Here what I'm going to do, okay, summation is over. So we should need to find the length. Then I say if summation is equal to k, yes, if the summation is equal to k, then the length equals to max length comma max length comma j minus I plus 1. J minus I plus 1. What is this j minus I plus 1? This is going to give the length. This is going to give the length. How it's going to give the length? So I say, what is the length of this? What is the length of this? This is absolutely, the length is 2. What is the length of this? The length is 3, right? The length is 3 for this. So here is the I pointer. Here is the j pointer. What is the length? Here the length is 2, right? So this is how it's going to give the length. For that I write I minus j plus 1. J minus I plus 1 to get the length. To get the length. Okay, this is it. So okay, at last I'm going to print the length. Print the length of the longest subarray. That's it. That's it. Let's try to analyze the time complexity for this. So what will be the time complexity? What will be the time complexity? I think I say we're using the time complexity will be approximately, approximately. It will be big O of n cube, the time complexity, big O of n cube. But the interest is, no, you should change, you should optimize this time complexity. It is too big. It is too big, right? For that I can say, what I can do here is, I'll just try to remove this loop. What I'm going to do, I'm going to remove this loop, remove this, and I say, here what is happening, here let's try to understand. Whenever j pointer is moving, then we are getting this subarray. Whenever the j pointer is moving, we are getting this subarray. We are getting this subarray, right? Whenever the j pointer is moving, we are getting this subarray. We are getting this subarray. What I'm going to do is, I'll add a summation here. Here, I'm going to add a summation is equals to 0. I'm going to add the summation as equals to 0. And I say, summation of s plus summation is equals to array of j. So I'm going to add this. What I'm going to do here is, I'm going to add this. this subarray. I'm going to add 2, 3. I'm going to add 2, 3, 2, 3, 1. I'm going to add 2, 3, 3, 1, 2, 3, 3, 1, 1. I'm going to add 2, 3, 3, 1, 1, 4. I'm going to add this. I'm going to add all of the subarrays in this loop only, right? Okay. If we do this, now the time complexity will be, a roundly big of n square, big of n square. This is what I do to reduce the time complexity for the brute force solution. So this is a brute force solution. The time complexity we have got is big O of n square. Roundly, it's not the correct value. It's p roundly, right? Okay. So okay, now we are going to look the better solution. So we're going to start the better solution. Let's look for the better solution. Okay, right. So how can we implement the better solution? I say we can do the better solution using hashing. Using hashing. We can do using hashing. So before that, let's try to understand what I'm going to do. Let me explain my thought process. So here we have given an array. Let's try to think. So these dot are the elements. Dots are the elements. I'm going to say summation is equals to k. Right? Summation is equals to k. And I say here the sum is equals to. So this is a subarray. 2, 3, 1, 2, 3, 4, 5, 6. So okay, this is a subarray. I'm gonna say this is a subarray. Okay. And this length of this subarray is x. I said the length of this subarray is x. Okay. Then I say this is my element k. I say this is my element k. I say this. I say this is my k. This last element is my k. You get last element is my k. Okay. Then what will be this? What will be this? This, what is this? If this subarray length is k, then what will be this? What will be the length of this? What will be the length of this subarray? So here the entire subarray length is x, right? Then what will be the length of this? I say this will be x minus k. It will be x minus k. Okay. What is this? This is a prefix. What is this? This is a prefix. Prefix. That means it is here. It is going. It is going from right to left. Then I say this is a prefix. I say this is a prefix. This is a prefix. Prefix sum is x. So this. Okay. What I'm gonna do here is I say if there exist a subarray with summation is equals to k. If there exists a subarray with a summation equals to k, then as dot as the last element, as the dot as the last element, dot as the last element,
Sorry.
dot as the last element. So okay, this is pretty much confusing. I understand. Okay, let's just go to the exact thing. Let's go to the better solution using hashing. So we're going to do this using hashing. And I say hashing. How I'm going to do is using hash. What I'm going to do. So I have an array. I have an array. So let me take this array. Where is that array? Yeah, it's here. I'm gonna take this array. Okay, I need this as a copy. I say I'm gonna paste this here. I say paste. Yes, okay. So I have got this array. I have an array. I have an array. What I'm gonna do here is, what I'm gonna do here is, I say, I'm gonna take a hash map. I'm gonna take a hash map. Yes, this is my hash map. This is my hash map. Okay. What I say is summation. What I say is summation is equals to 0 and the length is equals to 0 because length, we don't have any kind of subarrays in the hash map. So initially it will be, length will be 0. Okay, I say, I'll go to the first element. I'll go to the first element. I say, when I take the first element to the hash map, then the summation will become 1, right? Summation will become 1 and I write the index as 0. This is a, let me write the index 0, 1, 2, 3, 4, 5, 6, 7, 8. Here the k equals 3. We should find this, right? Okay. So this 0 is the index. This 1 is the summation. This 1 is the summation, right? Okay. I say, then I move the pointer. Now the summation will become 2. I put into the hash map. Now what is the index? What is the index? The index is 0 plus 1, 1. 1. No, 0 plus. Now the index is 2. Then the length of the array is 2. Okay. What is the summation now? What is the summation now? What is the summation now? Summation is now 3, not 2. It's 3 now. 1 plus 2, 3. The summation is 3. Okay, summation is 3. Then k equals to 3. Then can I say this is my length? No, this is 2. This is not the longest subarray. This is not the longest subarray. Then I say what I'm going to do is I'm going to put into the hash map. I'm going to put this into the hash map. The summation and the index is 1. The index is 1. And I move the pointer. And I move the pointer. What we got here? 3. 3 plus 3. The summation is 6 now. The summation is 6. The summation is 6. I'm going to put it into the hash map. The summation is 6 and the index is 2. And the index is 2. Okay. What I can say here is, say here is, this is my first element. This is my second element. This is my third element, right? This is my first, this is my second, this is my third. So the total summation is 6. Summation is 6. We got summation is 6. Okay. For this, the summation is 3. For this element, the summation is 3. Then 3 plus 3 is equals to 6. Right. Okay. Can I say this is my, this is my length? No, this is not my length. This is only the length is 2. Right. Okay. So this is how it's going to work. This is how it's going to work. Okay. I'll move the pointer. I will move the pointer. I'll go to here. Then what will be the summation? The summation will be 7. 3, 3, 6, 7. The summation is 7. I say 7. 7 point was pointing to the index 3. I say 3. Yes. Then I move the pointer. Then I move the pointer. Then what will be this? Then I move the pointer. Then I move the pointer. Then the summation will become 8. Then the summation will become 8. And I put it into the hash map. The hash map summation is 8 and index is 4. Then I move the pointer again. Then the summation will become 9. Then the summation will become 9. And the length is 5. Here I can say 1, 2, 3. 1, 2, 3. Here there are 6 elements here. 6 elements here. And I have a summation value as 9. Okay, I have a summation value as 9. So for this, the summation is 6. For this, the summation is 3. I've got the 3. I've got the length 3. And I've got the length is 3. If I say 6 minus 3, it's 3. 6 minus 3. The summation is 3. Then what will be the length? What will be the length? This is the summation. This summation is, we have got 3. Summation is equals to k. Then check the length. Then check the length. Then check the length. How are we going to check the length? So this, I'm going to say, for this array, we've got this 2. For this subarray, we've got here is 5. I say 2 minus 5 is 3. Is 3. We've got the length. We've got the length. I'll write here this. Let me write here. I say 1, 2, 3. I say 1, 1, 1. So this is a subarray, and this is a subarray. Here index is 0, 1, 2. Here the index is 4, 5, 6. No, so 3, 4, 5, 6. 3, 4, 5. Right? This is my index for this summation. This is my index for this summation. What I'm going to do is, to find the length, to find the maximum length, I say 2 minus 5 equals to 3. So I have got the length, maximum length as 3. Maximum length as 3. So this is my longest subarray. What I say? This is my longest subarray. This is my longest subarray. So let us try to analyze the time complexity for this. I say time complexity will be ego of n logarithmic n. I say n logarithmic n. So this time complexity is for unordered map. As this time complexity is for ordered map. So we use an ordered map. So the time complexity will be ego of n log n, n logarithmic n. Logarithmic n because we are using the ordered hash map. Ordered hash map. Then I say, what will be the time complexity if we use unordered map? If we use an unordered map, then the time complexity will be big O of n into 1. I said big O of n into 1. Big O of n into 1. If it does not have any collisions, if it does not have any collisions, then the time complexity will be big O of n into 1. N into 1. What if it has the collisions? Unordered map has the collisions. Have collisions. Then my time complexity will be n into n. That is approximately, it is n square. It is the approximate value. Approximate time complexity. Approximate time complexity. That is big O of n square. Big O of n square for the unordered map, which will have the collisions. Which will have the collisions. Then I say, what will be the space complexity? Space complexity will be big O of n. Big O of n at the worst case. At the worst case. At the worst case. Why big O of n? Why big O of n the space complexity at the worst case? If I say at the worst case, every prefix sum is storing value individually. Storing, or if all of the values are individual, all of the summations are individual value we should need to store that in the hash map. At the worst case, right? This will be the worst case. Then the space complexity will be big O of n.